All right, so we're classifying the phrases. Does each phrase describe a kinase, phosphatase, neither or both? And so we have a group of phrases down here in all our answer bank, right? And then we're looking at the classes of enzymes, right? We have the kinases, phosphatases that we need to look at here, and then some of these won't be either of them, right? And some will be both. Okay. So the first thing you got to do is, what the hell is a kinase and a phosphatase? What is that? Can you give me a... So you do have to memorize these classes of enzymes. You'll need to know them and know them pretty well. Okay? So especially so you can recognize them and understand, which one's which. Okay, so first off, phosphatase, what do you think that involves? Yeah, some sort of phosphate group, right? More specifically, if we have an enzyme, what does that mean if it's an enzyme? Does it only go one direction? No, enzymes go both directions, right? So in the case of a phosphatase, you're going to be taking phosphate groups off, right? Or putting them on, okay? But remember that phosphatases every enzyme always goes both ways, right? Never just goes in one direction, okay? Okay, kinases, what do you think that's going to mean? Yeah, so it's going to use energy, right? One of the primary forms of energy being, ATP. Yeah. Readily available energy in the body is typically in the form of ATP, right? And so a kinase is going to add phosphoryl groups, oftentimes using ATP to provide that energy, but it could also be removing them, right? The reverse. Remember, all of them always work in both directions, right? Okay, but notice that it doesn't just add a phosphate group onto there, right? So that's where that sort of differs, okay? It's going to be providing it as energy. Typically means adding a phosphoryl tail of some sort. Okay, so I don't know which one's easier to go. Let's just go from the start and then go down the list, okay? Oftentimes it's easier to go both neither first and then go on, but we'll see. Okay, so kinases, let's see, add phosphoryl groups to proteins. Well, a phosphoryl group, we're talking about like an ATP or something, right? And so that makes sense. May use ATP as a phosphoryl group donor. Well, ATP is the most common phosphoryl group donor, right? And so, yeah, that has to be, right? pKa, protein kinase A, is an example. I hope nobody had difficulty with that one. It only says it in it. It literally says exactly what it is, doesn't it? The naming sense was pretty straightforward. Okay. Yes, kinase, right? Kinase. All right, just to be sure. Okay, so this is phosphatases. Again, enzymes typically are what they do, right? With an ACE behind it to indicate it's an enzyme. Okay? That's what these classifications boil down to. So it catalyzes dephosphorylation reactions. Well, that isn't a kinase because we're just taking off a phosphate, right? We're not taking a phosphoryl group on there or off of there to provide energy or remove it, right? So it's a bit of a different thing. You see that shade there, that difference? Turn off signaling pathways triggered by kinases. Well, okay, so turn off a signaling pathway triggered by a kinase. So now we're taking this and we're chopping on a phosphate group to turn it off, right? And so phosphatase makes a lot of sense. Kinase doesn't really make sense because you're turning off the pathway. The kinase triggered it, right? You see where that would be a... Yeah, it's probably this other thing, right? I always try to give you guys the ability to reason it out, or at least see how I did that. Hopefully it works. Hopefully, huh? All right, so in eukaryotes, transfer phosphoryl groups to acidic amino acids. Okay, so anybody want to try this one? Okay, so the only one that really could be right is kinases. Okay? That's the only one that make any sense there, right? But it has so much more details in this, doesn't it? Yeah. So we have eukaryotes transfer phosphoryl groups to acidic amino acids. But does a kinase only do that? No, kinases are much broader groups, right? That sounds like it could be some specific enzyme, right? But not a group of enzymes, not a category, right? Catalyzed reactions, they're the reverse of dephosphorylation reactions. Okay, so these are mutually exclusive, aren't they? Yeah. So we have catalyzed dephosphorylation reactions and catalyzed reactions that are the reverse of dephosphorylation reactions, right? And so, no, these don't go directly reverse each other, okay? In these cases, phosphorylation, typically you have a slightly different pathway and slightly different enzyme group, okay? That will accomplish that. And those are neither of those. Both is regulate the activity of other proteins. Yeah, that's typically what these both accomplish, right? They're used to regulate activity, specifically cause signaling cascades, because, it's an enzyme. So it would continuously produce its product until it runs out, right? And the fact that these enzymes are acting on other proteins and enzymes means you get an amplification effect, right? Okay. So you can actually get tremendous effect from phosphatases and kinases. Does anybody have any questions about any of that? No? Okay. Does it help that you can sort of reason these things out, hopefully?